Hello and welcome to this video. In this video, we are going to study about what are R values, what are their uses, and what facilities do they provide, along with the functions which are provided by the compiler for free, and when do we need to implement those. So there is something called L value, there is something called R value. So L value is something whose address can be taken, and R value is something whose address cannot be taken. By address, I mean memory address. So for example, consider this A is equal to 5. You cannot take address of 5. You cannot say ampersand 5. But after this variable is created, you can definitely say ampersand 5. So the other meaning of L value is that whatever can appear on the left side of assignment, that is R value, L value, and whatever cannot be placed on the left side of assignment, we call that R value. So we can say A is equal to 5, but we cannot say 5 is equal to A. That won't work. These are usually produced by expressions like A plus 1 or 10 or returning temporary values. It is meant to be used temporarily, and it does not hold memory for long term. And the fourth most important fact is that it allows move semantics. We will explain in a moment what is move semantic. So consider, for example, we have A is equal to 5, and we declare X as an R value. R values are shown by double ampersand. We assign 10. Then we have two overloaded functions. One takes a reference, another takes an R value of X. So if you pass A, it will print L value because it's an L value. But if you send 10, it will go to R value. A plus 1 will go to R value as well. Now, as you can see, we have written it in the R value form. But do you think that this X will go to R value, or rather it will go to the L value? So we will find that out in a moment. Once we compile the program, it will be clear. So let's see. Okay, so I have already compiled the program, but for your reference, I will R value. Okay, so this is the compilation command, and we compile it, and then we run a.out. And as you can see, the last call goes to L value. So just by typing ampersand won't make it L value. It has to be a temporary. Otherwise, it will be treated as an L value here as well. Now we look at the uh, uh, functions provided by the compiler. So in general, as I said in the last video or before that, I think these are the functions provided by the compiler for free: copy constructor, copy assignment, move constructor, and move assignment. Take careful take careful note of in what syntax they will be invoked. The copy constructor is meant to create an object by copying. We have already covered the copy constructor. Then we have assignment operator where we copy or rather assign an object to another object. So this is called copy assignment. And then we have move constructor where we create an object by moving another object. And then we have move assignment where we assign an object by moving. So std move is the move, it provides the move functionality. Now we have already seen copy constructor and copy assignment in earlier videos. So we'll see how move constructor and move assignment work and how we can work around that. So for example, we have a class string which has a data member char pointer data. Now the default constructor, we initialize this data and make it contain null, and it is default constructor. In parameterized constructor, we receive a string argument. We allocate memory for string length of that string argument plus one because we need to store null character also. And then we copy by using strcpy, and that is our parameterized constructor. Copy constructor you have already seen. You need to allocate memory for the destination and then you copy the data. Copy assignment operator or overloaded assignment operator is similar thing. You compare whether the object on which the assignment is invoked is not equal to the source. This other is source and this is destination. So if they are not equal, you delete the data of this object and you allocate memory again and you copy the data. So these two we have already seen. Now move constructor is special. Here you have to receive R value. You can't receive it as L value. Move constructor and move assignment operator both require R values. And these are no except. No except means the functions won't throw any exception. We have not yet covered exception, but in general, you can assume that it is not going to throw an error. You see, in this case, we do not allocate memory for data. We simply say other dot data. And std move will ensure that data is moved or rather pointed to it. Is basically you're pointing to that, and then other dot data becomes null ptr. So this is your move constructor. And then we have move assignment operator. It is similar. Notice that here you are sending a reference to string. Okay, the return value is a string. So it is similar to move constructor. It is a mix of move constructor and assignment operator. So we do the same thing. We delete data and we copy the data, and other data is null ptr and return pointer this. And in destructor we delete the data and prints the data. So you see S2 and S3 we have seen already, I believe. Yeah. Now S4 is created by moving the S1 object. It is a constructor call because the object is being created here. Here the object is created and then object is assigned by moving the another object. Now see S3, S4, S5 will print the data. Okay, and it will also print other messages, default constructor and all. So let's run this. So cpf dot. Okay, we are in the wrong folder. cpf dot cpp. So we run this, and this is parameterized constructor call, and then we have copy constructor, then we have default constructor, and then we have assignment operator, then we have move constructor, then default constructor, and then move assignment operator, followed by 3 hellos of this print and followed by 5 destructors of the 5 objects you have created. Now, after you move an object, it is bad idea to print, to use that handle, okay? So this s1.print should not be used because we are going to invoke dereference the data, okay? It is not a good idea. So suppose we do that, then the behavior is implementation defined or undefined or whatever, I don't exactly know. So if you do /a.out, then you see the program terminates abruptly. After 3 hellos, it is not printing destructor calls, while it should have printed the destructor calls. That means if you look at $, it is still 0, okay, because whatever is causing the termination, it is sending 0. So the destructor calls did not happen. So there will be memory leak here. If the object is long running and this is some other function other than main, but in any case, if you are terminating the program, then memory leak does not matter. But the point is that destruction is not happening properly. The objects are not being destroyed. So this call is terminating the program. So once you move an object, you should not use its handle. That is something you have to take care of. And that is why Rust is a very good language, because if you move in Rust, Rust compiler won't compile your program if you put that line number 99 in your code. But C++ compiler is not that strict. It relies on you that after moving, you are not going to use the handle. So the typical idea, what we do is if it's a pointer, we set it to null. But here it's not a pointer, we can't set it to null. So with this, I would like to end this video here, and in the next video, we will talk about public, private, and protected stuff and what is their relation to inheritance. So in the next video, we will talk about inheritance, and once inheritance is done, we will see how friend classes and friend functions work, and then we will move on to virtual functions and polymorphism and abstract based classes and so on. So I hope that you have found this video useful and informative. So uh, I'll see you in the next video on 4th day from hence, and thanks a lot for watching the video. Keep learning and enjoy.